Hello. Till now, we have studied about Ohm's law. In 1942, German physicist Kirchhoff extended Ohm's law to complicated circuits and gave two laws which enable us to determine current in any part of such a circuit. Today, in this video, we will study about the Kirchhoff's laws in detail. Before we move to the Kirchhoff's law, you must know about some terms. The term electric network is used for a complicated system of electrical conductors, and any point in an electric circuit when two or more conductors are joined together is called a junction. Next one is loop or mesh. Any closed conducting path in an electric network is called a loop or a mesh. And the fourth one is a branch is any part of the network that lies between two junctions. Now, Kirchhoff's first law, or you can say junction law or Kirchhoff's current law. In an electric circuit, the algebraic sum of currents at any junction is 0. In other words, you can say that the sum of currents entering a junction is equal to the sum of currents leaving that junction. Mathematically, you can say that summation of I is 0. Let's understand with the help of this diagram. In this diagram, at point O, there are 5 currents, and some of the currents direction is towards the junction O, and some of the currents direction is out of the junction O. You have to use sign conventions that the incoming current towards the junction are positive and outgoing currents, that means away from the junction, are taken negative. Now, again consider above diagram. You can see that the current I1 is incoming current. That's why it is positive. Current I2 is outgoing, so negative. I3 outgoing, so negative. I4 incoming, positive, and I5 outgoing, therefore negative. So mathematically you can write I1 minus I2 minus I3 plus I4 minus I5 equals to 0. You know that the charges cannot accumulate at the junction. The number of charges that arrive at a junction in a given time must leave in the same time according to the conservation of charges. Now, second law, or you can say voltage law or the loop law. Around any closed loop of a network, the algebraic sum of changes in potential must be 0. In other words, you can say that the algebraic sum of EMFs in any loop of a circuit is equal to the sum of the products of current and resistances in it. or you can say the mathematically summation of delta V is equals to 0. Kirchhoff's loop rule is based on the conservation of energy because total amount of energy gained and lost by a charge around a closed loop is 0. Now, next thing we have to decide to apply second law is that whether we will traverse the loop in a clockwise direction or in an anti-clockwise direction. And answer is that the choice of direction of travel is arbitrary. But in the same question, if you have to consider 2 or 3 loops, then consider the same direction. Means if in first loop you have chosen the clockwise, then in that particular question, take all the directions clockwise or anti-clockwise as of your choice. Now, the sign conventions. When traveling around the loop, if the resistor is being traversed in the direction of current, then the potential difference change across it is negative. You know by Ohm's law V is equals to IR and we have to take the negative direction. And if the resistor is being traversed in the direction opposite to that of current, then we have to take I into R positive. If a source of EMF is traversed in the direction from negative terminal to positive terminal of the EMF source, then the change in electric potential you have to take is positive and vice versa will be taken as negative. Now, see the application of the loop law from this diagram. In this loop, A, B, C, A, we have chosen the direction first and you can see that this direction is, yes, identified as clockwise. Now, let's apply. While moving from A to B, we move from the positive to negative terminal of the battery. So, I will take it as minus E1. Now, the next one, the I1 current is flowing. That means I am traveling in the opposite direction of the current. So, I will take I1 R1 as positive. Now, while moving from B to C, nothing is there, neither the battery nor the resistance. From C to A, I have R2 and the direction of current is opposite to that of my direction of traverse. So, I will take the potential as I1 plus I2 into R2 and that is also in the positive direction equals to 0 according to the second law. Now, consider the second loop and apply the same rule and you will get this one. And note it down the sign conventions. And you have to note that the path can be traversed in the clockwise or anti-clockwise direction of loop, but take care, try to take the same direction in one question. Now let's discuss this numerical problem. This is the problem 3.7 of your NCERT and you have to find out the direction of current in each branch of the network as shown. Now by following the Kirchhoff law, you have to find the junction law and the loop law. You have to find out the equations first and then solve the equations and find out the value of the current. Now, again, I have drawn the same figure here. Now, by applying the loop law in the loop ADCA, you got 10 minus 4 into I1 minus I2 plus twice of I2 plus I3 minus I1 minus I1 equals to 0. And for the closed loop ABCA, you got the equation 10 minus 4I2 minus twice of I2 plus I3 minus I1 equals to 0. And for the closed loop BCDEB, you got 2I1 minus 4I2 minus 4I3 equals to minus 5. And by using these three equations, 1, 2, and 3, you can find out the values of I1, I2, and I3. And you can clearly see that the total voltage drop across the closed loop BADEB is 0 as it is required by the second rule of Kirchhoff's. Try to solve some more problems given in your NCERT and ask if you have any doubt. Thank you.